Hi everyone, this is MK and here is another LeetCode Daily Challenge. The theme of this week is about valid parentheses. All right. And this is a more complicated version comparing to the previous 2 days. In this case, we have a string and we should figure out whether this is a valid parentheses, but there is some catch. Let's read the problem. So the input contains of left parentheses and right parentheses and asterisks. And what is the asterisk doing here? So we can choose to treat an asterisk as a right parenthesis or a left parenthesis or an empty string. We can totally ignore the asterisk. So it's up to us what to do with that asterisk. But at the end of the day, we should figure out, based on this flexibility that has been given to us, is the input a valid parentheses string or not. And I'm assuming that you know what a valid parentheses string is. Each left parentheses should be matched with the right parentheses and vice versa. So if you look at the first example, we have open parentheses, we have closed parentheses. Simple. The second one is also simple. We ignore the asterisks in the middle. Basically, we treat it as an empty string. And the third example is also an easy one. So we have one asterisk and we just match it with this right parentheses, and here we are. So the answer to all of them are true. There's no example that the answer is false, and I'm assuming because if they give you an example like that, it is gonna be revealing to you some information about the solution, probably. The constraints are like 100. It's not that big, so we can do n squared or n cubed even. And of course, the string is composed of open, close, and asterisks. So how do we think about this problem? So for a second, let's assume that we only have open and closed parentheses. How do we solve that problem? How do we figure out if a string is a VPS, a VPS, valid parentheses string, if we don't have asterisks? We get a stack, right? So we have something like this. So open, open, close, close, and we have some stack that keeps track of the open parentheses, right? Here, when we are here, it's an open, we push it to the stack. When we are here, it's an open, we push it to the stack. When we are here, it's a closed parentheses, it's a right parentheses, so we should look for an open parentheses. So we look at the stack and say, hey, do you have an open parentheses? And the stack says, yeah, I do. So we match them and we pop the stack. So this closed parentheses has a match. Now we move on to the next one, and again we check for the stack. Hey, stack, do you have an open parentheses? And yes, again, and we pop it, and there we are. That's it. This is when we don't have any asterisks. All right. So let's say we just develop this solution and solve it with 2 stacks. So this is the second example, I think. Yeah. So instead of 1 stack, let's have 2 stacks. One for the open parentheses and one for the asterisk. So this is the open parentheses. I'm going to call it open. And this is the asterisk. I'm going to call it ast. Okay, and that's it. So let's check the string. So this is open parentheses. We add it to the open parentheses stack. This is asterisk. So we add it to the asterisk. Okay. Now we are checking this closed parentheses. So when we are checking the closed parentheses, what we do is it's better to match from the open parentheses first. It's better to match from the open parenthesis first. So in this case, we check the stack and say, hey, a stack, open stack, do you have any open stacks there? And it says yes, so we match it. So we get rid of this. We get rid of this, and we have basically matched this with this one, right? And then we move on to the last close parentheses, and here we check the open stack. There's nothing here. So we go to the asterisk stack and say, hey, do you have any stars left? And it says, yes, I do. And we match them. I don't get into the details of why this is correct, because this doesn't make sense, like matching these two and then matching these two. But you can do a swap. Just think about what kind of swaps you should be doing to make this matching make sense. We don't need that. We don't need to print the output. The output is just a true false. But you go ahead and think why this makes sense. We can just do a swap. And where does this swap happen? Anyway, but is that enough? Is this enough? No, it's not. So at the end of the day, in the original problem, when we finish our checking, we checked the open parentheses. So let's say we have this and something like this. Okay, so during our check here, each time we see a close parenthesis, we have an open parenthesis to match. Each time we see a close parenthesis, we have an open parenthesis to match. But whenever after the algorithm finishes, we have two open parentheses and they don't have any matches. So if you remember in the original example, we check if after the for loop, we check if open is not empty. If open is not empty, we return false. This is not, yeah. If open is not empty. This is the original problem. But what do we do here? What happens here? So when we are finished, we do the same thing. So we check for the open. If open is empty, we are good. So if open is empty, let me write it here. Yeah. After we are finished with our for loop, main for loop, here we check if open is empty. What does this mean? That means we finished our for loop. Every close parenthesis has a matching open parenthesis. And at the end, we don't have any open parentheses that aren't matched yet. Perfect. That's it. We are done. We return true. But what happens when we have something in the open parentheses? What is that scenario? Is it enough if we have as many open parentheses as we have asterisks? Is that enough? No, it's not. Let me give you an example. So let's say this is our example. So after we are finished, in our stack, in the open stack, we have one open parenthesis and we have one asterisk. This is good. But this is another case that is not good. So after we are finished, we have one open parenthesis in our stack and we have one asterisk in our stack. But this is not good. So in order to fix this, we need to keep the indexes of the parentheses and of the asterisks. And after the for loop, the main for loop finishes, we go here and say, hey. The top of the stack, the top of the open should happen before the top of the asterisk. Like in this case, let's say we add indexes here. Okay. I'm talking about this case. So this is 0, this is 1, this is 2, this is 3. These are indexes. So the asterisk is 2 and the open is 3. This is bad because the asterisk is not happening before the open. This is bad. But in this case, let's talk about this case. In that case, these are swapped. So basically open is happening at 3. Sorry, open is happening at 2 here. And asterisk is happening at 3 here. So when we compare the top of the open with the top of the asterisk, that is good. We can match the two. Right? So let's go and write the code. I'm going to explain more details if necessary there. So we need 2 stacks, right? Stack of integer because we are keeping the indexes. So I'm going to call it open. We need another stack for the asterisk. So I'm going to call this ast. Okay. And then we do a for loop. So for loop int I is 0, I less than s.size I plus plus. So we take C, which is s of I. If C is open, if C is open parentheses, we just add it to the open. That's it. We don't do much here. So open.push I. If C is equal to asterisk, again, we just add it to asterisk stack, and that's it. We don't do much again here. But if it's a closed parenthesis, if it is a closed parenthesis, there are different scenarios. First, as I said, we try to match with an open parenthesis because they have a priority to be matched. They are mandatory to have a match, but the asterisks, they don't. There is no it's not mandatory to match for the asterisks. So here basically, so C is equal to a closed parenthesis, and we should match it to an open parenthesis, Okay. So first we check for the open parentheses stack. So we say if open.empty. If open is not empty, perfect. We take something from the top of the stack. So open.pop. Perfect. Else if. That means open was empty. So we check for the asterisk. So if asterisk is not empty. Good. We match with that asterisk. So we say asterisk.pop. Awesome. Else, that means we have a closed parenthesis here, and the open is empty, and the asterisk is empty. So that is that tells us that we cannot finish this string. So we return false. Yeah, that's bad. We return false. Okay. So this is our main for loop. That's it. So here we should check open stack. Open parentheses, I think. A stack. Parentheses, yeah. Okay, yeah. So here, while, let me check. So if open.empty. If open is empty, we return true. That's it. That's it. We are good. We don't have any open parentheses that aren't matched yet. We return true. All right. Otherwise, so here we should check while open is not empty. While open is not empty, what do? We should check the top of the open and the top of the asterisk. So if asterisk.top is greater than open.top, this is bad. This is bad. That means the latest asterisk is occurring after the latest open. Actually, this is good. Sorry. This is good. Yeah. If the asterisk comes before the open, this is bad. This is bad. This is like this. This is like this. Asterisk and open. This is bad. So here we return false. Otherwise, we just pop the 2. Like, otherwise this is happening. So we say ask.pop and open.pop. All right, and here we return true. Here it means that the open is empty. That means we could find a match for every open parenthesis that is left there. All right, and run. And yeah, 3 green flags and submit. Okay. We have just 1 open parenthesis. Okay. So that means we are gonna add it here. Okay. Oh, sorry. Here. We should check if asterisk dot empty. If asterisk is empty or asterisk dot top happens before this. Yeah. If we don't have any asterisks. Yeah. So let me use this test case and run. Yep. Good, and submit. All right, that is it. So I'm gonna, for the second solution, I'm gonna explain a DP approach. Okay, why a DP approach? Why? So one of the things that can hint you that you can apply a DP approach is this line. So whenever in a problem you have a situation that you can choose to do one thing or the other, and you have no idea which one is gonna result in the optimum solution, you can consider applying a dynamic programming approach. Because in this case, when you encounter an asterisk, you don't know, should I consider this as an open parenthesis? Should I consider this as a closed parenthesis? Or should I consider this as an empty string? These are actually 3 sub-problems in your dynamic programming approach. All right. So for a dynamic programming approach, there are a few things that you should come up with. So the first thing is the state. So what does that mean? That means f of, like, for example, for Fibonacci, it's gonna be f of n. This is the state. You're gonna solve the problem for a given n. This is like the state. And how do we come up with a state? To be honest, this is just I think this is more comes from experience and like an educated guess, right? So for example, in this case, one parameter of the state could be the length of the string, like starting from index. So I think f of index. So that means we want to solve the problem from index to the end. All right, so let's say this is your string. No, not that. This is your string, and this is index. Somewhere here. Index. That means you want to solve the problem from index to the end. What else do you need to be able to solve this subproblem? You need to know how many open parentheses you have here, right? You need to know that. So you add that to your state. Here. So I'm gonna add it here. Open count, something like that. All right. Is that enough? We don't know, but we can give it a try. Let's say this is enough. If this is enough, what is the answer to your problem? Let's say let's say function f magically solves the problem for you. Don't think about the details of how you can implement f. The first thing you should think about is, let's say we have f. How do you call f in the first place? So in the first place, you should call f of 0 and 0. So it means you want to solve the problem starting from index 0 and you don't have any open parentheses. All right. The next thing you should be thinking about is this is what you call the function in the first place. So the next one is base case. What is the base case? When do you stop doing any recursions? So that is when you are like when this is the emptiest string, when you don't have anything left to solve. You don't have anything else to solve. So that is if index is s dot size. All right. And in this case, do you return true or do you return false? So you check the open count. So if open count is 0, you return true. Otherwise, you return false. So basically, you return open count equals to 0. All right, this is the base case. This is the base case. The next thing that you need to think about is the recursion formula, which is the hardest part, but you cannot think about the recursion formula unless you know how to do these two parts. These two parts are the easier parts, all right? Now let's think about the recursion formula, all right? So based on s of index, so if s of index is open parentheses, what happens here? Sorry, okay. So if s of index is open parentheses, your subproblem would be f of index plus 1 and open count plus 1. So that means you, like f of index and open count, is solvable if this is solvable. That's it. Okay. If s of index is asterisk, what do you do here? So here we can choose to ignore this asterisk, like regard it as an empty string. So you can, so your sub problems, one of them would be f of index plus 1 and open count. So your open count doesn't change. Your open count doesn't change. You just need to solve the rest of the substring, the index plus 1. All right. And the other subproblem you have is f of index plus 1 and open count plus 1. And here we are considering the asterisk as an open parenthesis, right? This is an open parenthesis. This is the case when we are considering it as an empty string. So basically, I'm getting my subproblems from the problem description here. This is the problem description. It's telling me these are your subproblems. These are your subproblems. Like, all right. And the last one is if. If. So now we want to consider it. We want to look at it as a closed parenthesis. So if open count is greater than 0, then this is going to be your subproblem. Index plus 1 and open count minus 1. That means you regarded the asterisk as a closed parenthesis. And you or the answer to these three. So if one of them returns true, then you are true. Okay? And if s of index is a closed parenthesis, this is going to be simple. So if open count is greater than 0, if you have some open parentheses, you just match it and you call the subproblem. So here, if this happens, your subproblem would be f of index plus 1 and open count minus 1. That's it. All right, so this seems to be working. Yeah, and then that's it. Let's go and implement this. So let me delete this code. Okay, so I need a function. So int f, int index, or a start, or index, whatever. I'm gonna call it start, I think. Int start, and what else do we need here? Int open count. What else do we need here? String and s, and we need a dp table. So vector of int dp. All right. So the base case was if start is equal to s.size. That means this is an empty string. So we check for open count. So return open count is 0. If open count is 0, return true 1. Otherwise, return 0. Okay. Here, we should check if the answer is in dp. So if dp of start and open count is not -1. So -1 means this subproblem has not been calculated before. So if it's not -1, then that's good. Just return it. dp of start and open count. All right. And otherwise check for, so dp of start and open count is going to be 0, let's say. So we are going to assume that it's impossible. And then we are going to do our subproblems. So check if s of start is open. Okay. Then dp of start and open count becomes f of start plus 1, open count plus 1, s and dp. So that's it. You just call the subproblem and save the answer as the answer of yourself. Okay, this was this case. Okay, now we are going to check for the closed parentheses. So else if s of start is closed parentheses. So here we should check if open count is greater than 0. All right, so in this case, dp of start and open count is ORed. I know it's 0, but I'm just gonna OR it so you can see what we do with the subproblem. Or f of start plus 1, open count minus 1, because we matched that open parentheses with this closed parentheses, s and dp. That's it. Otherwise, nothing happens. If open count is 0, then dp of start and open count remains 0. Else, it's an asterisk. Okay, so dp of start and open count is ORed with f of start plus 1 and open count plus 1, s and dp. So this is where we are looking at it as an open parenthesis. Okay, then we look at it as an asterisk, like as an empty string, sorry. So here we don't increase the open count. And at the end, if open count is greater than 0, that means we can look at this as a closed parenthesis. So in this case, dp of start and open count is ORed with a start plus 1, open count minus 1, s and dp. And in this case, we are looking at it as a closed parenthesis. That's it. Yeah, And here at the end, we return dp of start and open count. And here, we need to define the dp actually. So int n is gonna be s.size. So vector of int dp is gonna be vector of vector of dp is gonna be vector of int. It's gonna be n plus 1 of vector of int, n plus 1 and -1. Yeah, this is always confusing for me. I think this is correct. Yeah, we are defining a vector of ints, n plus 1 of these vectors. Yeah, okay. And then we return f of 0, 0, s, and dp. I hope there's no problem. Yeah, that's it. And we just return and submit. All right, this is the second solution. The running time of this is O of n squared because of the subproblems. So we have n squared subproblems, and each subproblem is solved in O of 1, the time complexity. And the space complexity is again O of n squared because of this dp table. If you like my explanations, please suggest me to your friends. That's the only way I can keep producing these videos. Thank you very much for your support.